Today is going to be all about the circle formula once again, except we're going to mash it together with yesterday's talk about the FOIL method, binomials, all of that kind of stuff. So hopefully this can help solidify some of the knowledge for multiplying binomials. And just as a reference again, a binomial is just some set of terms inside parentheses that have a variable in it. So x plus 3, x plus 5, anything like that, those are binomials. It basically just means that there are bi, as in 2, and nomials meaning terms or numbers. So it's a two-term concept, and so by technicality 2 plus 5 is a binomial, but we know that we can simplify it, so those don't really count. So the reason I'm saying we're putting a mashup is because if, again, we think about the circle formula where we have x minus some variable h plus y minus some variable k, each of these is squared, and we're adding, and it equals the radius squared, we have two binomials. Each of these binomials we end up working with. So let's work with those binomials. Let's say that we're given a circle formula, x minus 3 squared plus y minus 1 squared. Make that a plus. This is the formula that we have inside of the slides that we're going to be working with. Now, this is equal to 6 squared. Now, right off the bat, what we should know is that this is a circle. Its center point is at coordinate -3, 1, and the radius is 6. So we should be able to draw out this circle if we wanted to, because we should immediately be able to tell that this is the x value for the center coordinates, and we basically just flip the sign that's given. This is the y value for the center coordinate, and we just flip the sign, and that this right here, since it is being squared, this is our original radius. Now that's something that we should get into the habit of. Any time we see a formula like this, immediately be able to tell what it is. Now we're going to split this up into 3 different sections. So we're going to split it up into x plus 3, into the y minus 1, both of them being squared, and the 6 squared, as to the left of the addition, to the right of the addition, and what it's equal to. And we're going to work with each of these separate. So now also I'm going to have over on the left a reference for the FOIL method, because we are only really going to be using the FOIL method as we expand this out. F standing for the first term, outer standing for the outside terms, inner standing for the inside terms, and last. Now this is when multiplying two binomials together. So let's take a look at that x plus 3 squared first. So x plus 3 squared. When we see a square, so first things first, x plus 3. We can't actually figure out what that is because we don't know what x is. X is just a variable. So let's just expand this out and see what we end up as our final value. When we square something, we have to remember that anything squared, 5 squared, is just that number multiplied by itself. 2 squared is just that number multiplied by itself, and the same thing goes for variables. X squared is just x times x. So in this case, If we're thinking of x plus 3 as what we're squaring, then this is equal to x plus 3 times x plus 3 being our term that we're squaring. Now we have our two binomials, and we're going to use our FOIL method to multiply them together. So we have to take a look at the first terms. So each of these binomials are two separate entities, and within those two separate entities they have a first term. So in this one right here, the very first term that we see reading from left to right is x. So we take x. So for our first, okay, so that's the first one done. We're not going to look at that one anymore. We're looking at our second entity. And the first term from left to right is x. Alright, so then we put down multiplying by x. And as we just said, well, x times x is the same as saying x squared. Alright, perfect. That is our first done. We are now going to look at outer. Outer looks at the entire equation as a whole. So it looks at everything from left to right. So outer basically means what is at the edges of our entity. What is at the very edge. So if we look all the way to the left and we start moving right until when we finally see a value, that's x. So that is the first value on the left that we see. So we're going to put that down as being multiplied. First one. Now we're going to go all the way over to the right because we should be closest to the outside of our entity. And we're going to move left until we find a value. That's 3. So that is what we're multiplying by between outer. That is the x, and that is the 3 here. Those are our outside terms. And since these do not mix together, we don't know what x is, so we're just going to set it as 3 times x. Now we're going to look at inner. Inner also looks at the entire equation as one whole entity, except it looks for the inside terms. So we have to first start at the middle. And as it so happens, this multiplication is our middle section. So from our middle, we're going to move right to see our first value on the right. So as we move right, we got the parentheses, we got the x, so the x ends up our first value on the right. So we're going to restart at the center. We're going to also mark down that x is the first one that we see. Now we're going to move left from our center. Left, we get the parentheses and the 3. The 3 is our first term. So we're going to multiply this by 3, and those are our inner terms. So now we're going to work with that and have 3x. Finally, we have last, L. So now last looks at these binomials as two separate entities again. So we're going to take a look at this x plus 3 as separate from this x plus 3. So these are separate when looking at last and first, but they are together when looking at outer and inner. So now that we're looking at last, we see the last term. So we're going to go from the left. We're going to go all the way. So x was our first term. Okay, so it's not this one. 3 is the next term, and then it just so happens that we end our binomial there, so we use our 3 as the last term for this left binomial. Now for the right binomial, we do the same thing. We're going to start off at the beginning of it. X is the first one that we see. 3 is the second, and then there's no more binomial to look at, so 3 is our last term. And what is 3 times 3? 9. So now we have a bunch of terms. All of these between f, o, I, and l. We combine those together to get our final equation. We take the x squared, we add the 3x, we add another 3x, and then we add our 9. Now we should be able to see that since these have the common x, that they should be able to add together because they have a common x. In this case, x squared, there are no other x squareds, so we can't add that into anything. And 9 doesn't have any x at all, so we can't add it in here. So then we add 3x plus 3x to give us 6x, and we have our final value, final part of the equation, as x squared plus 6x plus 9. Now that is just our left side. We're going to have to do the exact same thing for the y as well, but for now we're just going to hold on to this value here. So I'm going to put it up at the top so that we could remember that x gave us x squared plus 6x plus 9. And that's just going to stay up there as I clear the board for space. Alright, so now that we have some space, let's start off with this section. Because right now we did this. This one is done, we did it. So now let's look at y minus 1 squared. This one, after doing our first, we're basically just doing the exact same process. And so we should be able to kind of speed it up a little bit instead of writing down that our first is y times y. We should just be able to, in our heads, understand that. What is always helpful is writing out y minus 1 squared as its two binomials. Because again, when you square something, you take whatever the number is. In this case, that would be the y minus 1 that's being squared, and you multiply it by itself. In this case, y minus 1 times y minus 1, and when you're multiplying two binomials, we use the FOIL method. Y times y as our first, because these are the first terms in the separate binomials. That is y squared. Outer, so we look at the outsidemost for everything as a whole entity. So this entire equation, the outside terms, that would be y and negative 1. Y times negative 1 is equal to negative 1y. Now let's look at the inner. Inner being for the entire equation, negative 1 times y, another minus 1y, and then our last looking at each binomial separately. So the last term is negative 1, the last term is negative 1. When you multiply negative 1 by negative 1, well, a negative times a negative makes a positive, and 1 times 1, anything times 1 is itself. So now we have some similar terms where we have the y and a y, so we could combine these together. A negative 1 plus a negative 1 gives us negative 2. We drop down the plus 1, we drop down the y squared, and we get our y after we square it. So now this one is done, and so we could drop that down here as y squared minus 2y plus 1 as our secondary term. Alright, now we only have one thing left, and the only value we have left that we haven't touched yet is that 6 squared. We should know that 6 squared is just the same as 6 times 6, which gives us 36. So now we drop back in the equals, the plus, but we give the new values that we got. So this y minus 1 squared was the same as saying this right here, as y squared minus 2y plus 1. And on the left of the addition, where we had the x plus 3, we had the x squared plus 6x plus 9. And we add these two together. Well, let's see if we can add anything together. X squared, do we have any other x squareds? No. So we're just going to drop that down because there's no other x squared, we can't do anything with it. 6x, is there any other value that just has x in it? No. So we'll just drop that down. What about 9? Is there any value that doesn't have additional variables? No x, no y, no nothing? Well, we got a 1 right here, so we can add those together. So then we're going to get rid of both of these and instead just put down plus 10 because 9 plus 1 is 10. Alright, y squared. Do we have any y squareds in there? No, so we'll just bring it down. Do we have any y variables? Just y, nothing else. We take a look through? No, so we'll just drop that down as well. We have this equal to 36. Now, at this point, we might want to take our plus 10 here, and since, it's surrounded by a bunch of variables, it might not feel like it belongs, so we're just going to move it to the other side by doing its inverse. So positive 10 minus 10 would give us a 0, and always to remember, what you do to one side, you do to the other. So now we get left with an equation such as x squared plus 6x plus y squared minus 2y is equal to 26. Hopefully that has been helpful in looking into how FOIL works and how we multiply these binomials. Tomorrow we will be looking into how to go backwards. So from an equation like this, in fact we'll be using this equation into an equation that looks like our circle formula. Because backwards is a little bit different because we have to find the values we're looking for. We can't just use what's given. So hopefully that has been a little bit of a better look at FOIL and the multiplication. I hope you're enjoying your day. Stay safe and healthy.